Right now, beneath 30 feet of salt water, a rock is watching you. The ocean is quiet. The light is dim. You are floating above a coral reef, unaware that the jagged piece of limestone beneath you is actually calculating the exact wavelength of your shadow. The hunt has already ended. Do you believe in ghosts? To understand the octopus, you must first accept that you are looking at a biological impossibility. Most creatures on this planet are built around a central pillar of calcium. We have bones. We have a skull that acts as a fortress for a single centralized command center. We are structured. Is it possible to be intelligent without a shape? An octopus is a 100-pound bag of muscle and neurons with no fixed form. It is the ultimate expression of fluid dynamics in a living system. While you rely on a skeleton to resist the world, the octopus treats the world as a suggestion. It can squeeze through a hole the size of its own eyeball. Why does it do this? The answer lies in a mathematical constant called the degrees of freedom. Most animals are limited by their joints. Your arm can move in a specific, predictable arc because your elbow and shoulder dictate the geometry. An octopus arm has no joints. It has an infinite number of degrees of freedom. How do you control 8 limbs that can bend at any point along their length? This is where the math becomes terrifying. If your brain had to calculate the position of 8 jointless arms at every millisecond, it would simply crash. The processing power required would be astronomical. Dr. Guy Levy at the Hebrew University of Jerusalem has spent years studying this exact problem. He discovered that the octopus doesn't use a central command system for movement. It uses a distributed architecture. Each arm of an octopus contains more neurons than its central brain. Think about that. You are a single mind driving a body. An octopus is a committee. Each arm can think, taste, and explore on its own without waiting for instructions from the head. This is embodied cognition. Have you ever wondered what it feels like to have 9 brains? When a predator approaches, the octopus doesn't just run. It runs a physics simulation. The color appears. This happens in less than 700 milliseconds. That is faster than the blink of a human eye. Dr. Roger Hanlon from the Marine Biological Laboratory has categorized these patterns into 3 distinct mathematical groups: uniform, modeled, and disruptive. The octopus is not just changing color to hide. It is performing a real-time statistical analysis of the environment. It looks at the sand. It looks at the light. It calculates the average spatial frequency of the background. Then, it replicates that frequency on its own skin. It is a living algorithm. Can you imagine seeing the world as a series of textures to be solved? But color is only half of the equation. To truly outsmart a shark, you need depth. The octopus uses specialized structures called papillae to change its physical texture. It can make its skin jagged like coral or smooth like a pebble. This is 3D printing in real time. It is manipulating the way light reflects off its body. Most predators rely on edges to find prey. A shark's brain is a pattern recognition machine designed to find the silhouette of a fish. By changing its texture and color, the octopus deletes its own edges. It becomes part of the noise of the ocean. It creates a pattern recognition failure in the mind of the predator. Is it possible to be invisible while standing in plain sight? There is a cost to this brilliance. Most apex predators live for decades. A grizzly bear can live for 30 years. A human can live for 80. An octopus, with all its 9 brains and its physics-bending skin, usually lives for only 3 to 5 years. It is a high-performance machine with a short fuse. Why would evolution create something so smart and then give it so little time? It feels like a biological irony. You have a creature that can solve puzzles, use tools, and recognize human faces. Yet it dies before it can ever meet its own offspring. This is the software trade-off. Jennifer Mather, a researcher at the University of Lethbridge, has documented octopuses using tool use to survive. She watched them carry coconut shells across the ocean floor. They weren't eating the shells. They were saving them. They were planning for a future threat. The octopus would stop, stack the shells, and hide inside them when a predator appeared. This requires a sophisticated internal model of the self and the world. It requires a memory that can project into the future. It is not just running biological software to react. It is writing new code on the fly. Think about your own memory for a moment. You remember your childhood. You remember what you had for breakfast. You use these memories to navigate your day. An octopus does the same, but with 8 independent arms that might have their own memories of what a rock feels like. Imagine you are a crab. You see a coconut shell moving slowly across the sand. It looks harmless. It matches the non-threat template in your brain. You don't see the 8 thinking limbs tucked inside. You don't see the 3 hearts beating in total silence. The octopus is the only invertebrate that has been granted the status of a sentient being in several countries. This isn't because they are cute. It is because their neurological hardware is so complex it mirrors our own. They have a massive vertical lobe that functions like our frontal cortex. They can learn, they can play. They have even been known to escape from aquariums. They wait for the humans to leave. They calculate the time between security patrols. They unscrew the bolts on their tanks and crawl across the floor to the nearest drain. This isn't instinct. This is a jailbreak. How does a creature with no social structure learn to be so clever? Most intelligent animals are social. We learn from our parents. We learn from our peers. An octopus is a solitary ghost. It learns everything from scratch, in the dark, under the pressure of the deep sea. There is a concept in physics called the observer effect. The act of watching something changes the thing you are watching. When you look at an octopus, you are looking at a creature that is actively looking back at you with a completely different kind of mind. It is a parallel evolution of intelligence. It is the alien in the tide. If we ever find life on another planet, it might not look like us. It might look like a giant thinking arm with no bones. It might communicate through flashes of color and changes in skin texture. It might use math that we haven't even discovered yet. We often think of humans as the peak of evolution. We have the technology, we have the language, we have the big heads. But in the silence of the reef, the octopus is proving that there are other ways to win. It is a master of the biological glitch. It uses the physics of light to disappear. It uses the math of geometry to move. It uses the software of its distributed brain to outthink every predator that tries to eat it. It is a 500-million-year-old success story. Do you still think you are the only smart thing in the room? The next time you walk along the beach, look at the water. Don't just look at the surface. Look at the rocks. Look at the shadows. Somewhere down there, a creature with 3 hearts is deciding that you aren't worth the risk. It is running the numbers. It is matching your movement signature against its library of threats. It is adjusting its pixels to match the specific shade of a Sunday afternoon. It is staying perfectly still. It is waiting for you to walk away. The ocean is a landscape of sound and pressure that we can barely imagine. To the octopus, we are the ones that don't compute. We are the strange, heavy giants, with the synthetic smells and the metal boats. We are the neophobic triggers. Maybe that is why they hide. Not because they are afraid, but because they have already solved us. They have run the simulation and decided that we are just another part of the background. We are the noise, they are the signal. We spend so much time looking for life in the stars. We build telescopes and send out probes to listen for a whisper of intelligence. We forget that we share a planet with a creature that has been running a physics engine for 500 million years. The mystery isn't out there. The mystery is down there. We can study their brains. We can map their chromatophores. We can record their behavior in high definition. But we will never know what it feels like to be a distributed mind. We will never know the raw, subjective texture of having 8 thinking arms. The gap between us and them is not a wall. It is a spectrum. We are all just different versions of the same evolutionary code, trying to solve the same problem of survival. The octopus just found a more creative solution. It chose to be a ghost. So, remember the rock. Remember the light. The next time you look at a jagged piece of limestone in the tide, remember that right now, beneath 30 feet of salt water, you are the one being watched by math. And that's the big head theory. See you soon.